Thanks for coming out tonight to our Tech Talk on blockchain. First, I'd like to introduce our speaker. This is Dr. John Callahan, or Jack. And Jack is currently, he's been working at APL since 2006. He now serves as my chief scientist in the Applied Information Sciences branch. Before coming to APL, he's worked at various small companies. He also worked at Goddard. He was also a tenured faculty at West Virginia University, so quite a past. And as well, during his time at APL, he just came back from London where he served as a science advisor at ONR Global in London. And he has great stories to tell because he learned more about what was happening in DC when he was in London than what you learn about DC here, because everybody would go visit Jack and tell stories. So the talk tonight really came out of conversations between Jack and I on the future of computing, different types of paradigm shifts in computing, and this came out of that. And so it's a fascinating topic. I know about 3 weeks ago, there was a VP from IBM Research here at APL giving a talk, and I brought up blockchain during the talk, and his eyes peeked up and he said, yeah, IBM Research, we're worried about it because our big banking customers are worried about it, and we need to get on top of this. And it's an interesting technology. There was just a report that came out that it said it's one of the top 21 tipping point technologies by 2027 by the World Economic Council. And so, you know, I think there will be more to come on this. And with that, I'll turn it over to Jack.
All right, well, thank you, everyone. So, thank you, John. So, as John said, this came out of discussions about paradigm shifts in computing, and so I dove down on this technology fairly recently, so I'm far from an expert on it, but I do understand the ramifications. And I think what I'd like to share with you is if you go research this for yourself on the web, it's very hard to find a starting point. Lots of different stories happening, that are contemporary, some are past. A lot are political, not technical, and some of the technical articles dive very deep very quickly. So this is a slideshow I think I would have liked. So thank you for inviting me here because it motivates me to put these thoughts together. But I think I would have liked this as an introduction. So this does serve as an introduction, but it's going to take me 22 slides to actually get to the concept of blockchain. So bear with me because you need that build-up. That's really the way it's been structured in a sense as an introduction. Oh, I do have the clicker here. Okay. So I apologize for the trope of the iceberg, but this really is the case. So Bitcoin has, in effect, dropped off the radar scope recently, but now is coming back on, and primarily because of what's under the water here, the blockchain technology that supports it. So that's the primary aim of this talk. There's a lot of technical detail about the format of transactions, particularly the cryptography parts of a transaction, of the blocks themselves. I'm not going to go into that. There's a lot of material. The JSON format, for example, you can get lost in the weeds of details. What I'm trying to do is actually get to blockchain, why that's important, maybe some of the vulnerabilities, and then the potential beyond that. So just October 31st, this article in The Economist highlights the controversy, all here just in the headline in one paragraph. So the technology behind Bitcoin could transform the way the economy works, and it says, Bitcoin has a bad reputation. So even in the same article, the controversy comes right out in the headline in the first sentence. But it's in the news now. So we have to start, in effect, at 101 with money, banking, and so forth. So if you'll bear with me on this startup. But okay, bartering is where we started when I had a cow and you had 1 chicken and 1.5 pigs to trade me. But the problem is well, that half pig is really hard to negotiate, right? Once it's in half, it's dead and not much of value. So we wanted to exchange, right? Naturally, this is how we can survive as a society and move forward. So the invention of money, of course, introduced fungibility. And fungibility means that I can use it to essentially be a proxy for the value of goods and therefore fractionally exchange whatever skills or commodity I have for someone else. So I'm not an economist, but it's pretty straightforward. I'm sure you've seen this in Economics 101. But the problem becomes is who decides to use gold? Who makes the gold? Who decides who has how much? Where do I store it? When I have too much, it could get stolen and so forth. So enter banking. And for good or not, banking exists primarily as part of the system, including government, regulations, the banks, not only domestically but worldwide, as a system of creating, assigning value, keeping track of how much. Okay, we are very dependent on this as a society. Now, one important thing that the banks do is they don't, like Gringotts Bank in Harry Potter, they don't keep a little vault for everybody where we all have our own little bit of money. That's kind of quaint. But in fact, they basically have more or less a big pile. I'll get to that in a minute, where they actually don't even have that. But they keep track of how much you have and you have and you have, particularly in the same bank, through a ledger. Okay, and that ledger essentially is a historical record of various transactions, of transfers and withdrawals and deposits, and you hope they're correct at the end of the month. You know, I think we all still go through that almost line by line and make sure that everything is right, okay? Particularly when the balance seems off, okay? So we're very sensitive to these sorts of things. And it takes a lot of effort and time on our part. By the way, I'll put a plug. I'm not related to the author, but there is an exciting book called Double Entry, which is literally a book, and it's actually quite good, I understand. I have not read it, but it goes into the history of double entry bookkeeping, which is essentially one of the great advances in mankind, not just banking technology, but somebody wrote a book of this. This is what brought fame and fortune to Venice, right? So there's the book. I recommend it. I'm in the process of, it's one of the books on my pile. So one of the things the bank does, of course, is involved in transactions. This could be domestically or globally of, you know, what is this transfer? What does it mean? What are the fees involved? Keeping track of it so that I can buy something. So I call this sort of banking 1.0. And banking 2.0 is we don't even need the gold right now. These are just numbers, right? So they're keeping track of numbers that are being shifted. And, you know, the government creates new fiat money. The balance goes up, the number magically goes up in these institutions, and they'll be able to assign more, okay? They can give out mortgages. The actual money doesn't have to be there. We know about leverage and how much a bank has to hold and so forth. So the fact that these are numbers in a ledger becomes even more important, right? Now we're about to take that to a next level. And the next level is, so here's Bitcoin. So that's sort of the entry point to the blockchain technology, and it's been around for 2008, 2006 was the Satoshi paper. So that what you're really talking about here is a ledger of financial transfers. So I put a question mark saying it's more than that, but that's the starting point for our thinking about it. So here, for example, I have a set of previous transfers. I don't go into detail. This is each of these is a transaction. And I'm denoting that you start with 8, and I'm not assigning this. We can say bitcoins in this particular case because I am talking about it, that they are assigned to the blue and to the red person here, okay, again, who's the source of the inputs and the outputs of those. We can assume, for example, that all previous transfers leave a balance of 8 per person, just for this example. And down here I show you know, the ending balance of their accounts. Now, in current banking ledgers, you keep a balance, and that balance is kept by that bank, audited by regulators, okay, and by yourself. But for the Bitcoin set of transactions. You could replay from the first to the last transaction, and that's where the balances come up. There is no concept of a balance in each of these transactions here. Okay? So for each transaction, the ins must equal the outs. That if there's anything left over, that's not detracted from that person's balance. It's returned, okay? Whatever fractional amount is not spent here is returned to the person who put the ins. And by replaying that history from beginning to end, you can essentially get those balances, right? On the previous slide, I had effectively the tally of the balances, but that really only exists virtually by replaying the history from beginning to end, more effect, of the entire ledger. Okay, so you can think of this history of transactions as the entire ledger. There's various mechanisms, and these are the simplifications I warned you about on the first slide. There's ways that this is signed, parts of it encrypted, pointers to previous transactions, and so forth. All right, I'm not going to go into those details. You can find plenty of those primers. The Coursera course on Bitcoin, various books go into detail about the encoding of transactions and blocks. We'll get to in a moment. But the important thing I want to point out here is that they stand alone, more or less, and that the ins equal the outs here. Now, to go a little further, that ledger is visible worldwide. It's effectively published for all of us to see. That's another important part of this system. No one, in effect, owns it. Okay? It is visible to all of us. You and you and you could actually go from the beginning to the end of that historical record and verify how much you have, for example. Okay? Not how much other people have necessarily, right, because of the encryption technologies, but you, for things you own, for Bitcoins you own, you could look through that ledger and essentially get your current balance. So that is the public part of, and now not just transfers, but transactions as well. So this is a more general purpose mechanism than simply transferring. You do have to have as many ins and outs, but that's the Bitcoin application, that above the water part of the iceberg, right? But the general mechanisms here really support a richer model of computing in general, and that's what we're going to get to when we talk about blockchain. But this is the formation of the foundation, essentially, that you need moving forward. So more precisely, Bitcoin is a decentralized public ledger of transactions. So this really lives on a peer-to-peer network. The internet is one of the medium, of course, the primary medium for doing this at speed. But copies of the transactions and the history essentially are kept at various locations by various servers, and they're incentivized to keep this. That's part of the model through the awarding of transaction fees we'll see in a moment, okay? So people are incentivized essentially to keep these copies, to keep them up to date, to keep them relevant, to keep them effectively honest. It's part of the protocol, part of the infrastructure of doing this. And the decentralized nature is very much a part of this. So that really covers the essentials of what Bitcoin is doing. I've simplified it to transfers here. I've left out all of the internal encryption and signature parts. So as I said, this is the sort of intro I would have wanted before diving down, because they tend to dive right into the itty-bitty details of the transactions. So let me go through a 5-step process of, in effect, spending a Bitcoin and how it's done. Okay? And again, there's a simplification here, but it starts off by, let's say you're the red person here, and you want to send 2 Bitcoins, one to the green person, one to the blue person. So you start by step 1 by broadcasting, and that's in quotes there, a new transaction appears. The green and the blue person don't need to be online. They don't need to be part of the system. Okay? This is going to be recorded in the ledger. They can audit that later. They can look through the history and get that later that something was paid, okay? So they don't need to be part of the system online, right? This is not a synchronous operation for them. So, and who to send it to is another case here. It's a peer-to-peer network, so you don't have to send it to everyone. So the broadcast is in quotes. And in fact, these nodes will forward it to the other nodes, okay? So the first thing you do, and this is the only thing you do, quite frankly, is to actually broadcast that transaction. And there's various wallet technologies, so these are called wallet technologies, that allow you to tap into that network, create the transaction, and send it. So there are wallet websites, there's wallet software that will run locally, and they will connect to the peer-to-peer network, send your new transaction when you wanted to spend a coin. Steps 2 through 5 are going to be done by the network itself. Okay? So I put it on 5 steps, but steps 2, 3, 4, and 5 are done by the network. So when the network receives a transaction, those that receive it, so the one in the middle did not receive it at the moment, this node happened to forward it to this one. They append it, the new transaction, to the next block. And I will talk about what a block means, but for now, just it's a set of transactions, okay? So it's a window of transactions. There's no necessary fixed size. It could be from 1 to, I don't know what the upper limit on transaction numbers in a block is, but it's essentially a set of transactions from 1 to more. So it's appended to that block. Now comes the fun step. Attempt to solve the block nonce puzzle. So if there was one entity who could say, I've got the next transaction, I'm appending it, and that's it, I'm the authority, okay? That would be centralized. So how do you decentralize, in effect, appending and validating that transaction onto the next block? Well, you have a computationally hard puzzle. And this is where some of the mining comes in, okay? Mining happens to go back toward the things like the originator block and other blocks where the coins are essentially created. But effectively, those will run out. I forget the timeline, but it's an asymptotic curve where the mining rewards are decreasing, but transaction costs are increasing. So, or the transaction fees will remain. They're fractional, but they're enough of an incentive. So here, essentially, computing the solution to the block nonce puzzle is much more complicated, but essentially you are adding effectively a random value with the block that leads to, when it's hashed, leads to the most number of prefix zeros, okay? So there's a number of prefix zeros you're looking for, and that is computationally hard, and every 10 days gets a little harder, okay? So this effectively introduces a period of time where everybody is essentially on an equal footing, and they have to pick a value for a set of transactions. They can vary that window of transactions if they want that they're applying it to, and then try to come up with the nonce. It's basically a filler value, right? That when the whole block is hashed, essentially leads it with the prefixing set of zeros, okay, the most prefixing set of zeros, and that's set every 10 days. This particular node here in the network is not participating. They haven't got the transaction. They're working on something else, so they're just not part of it. So not everyone has to be doing this. Now, the warning here is there is a vulnerability, and I'm not going to dive into various attacks and vulnerabilities. There's a very live topic here, and I will mention a little later, that if a particular entity, not a node, but say an outside company owns, various nodes here, and they own equal to or more than 51% of computing, there is a vulnerability that they could delay the transaction validation and effectively corner that market. So they are watching for entities that are trying to get more than 51%. So that is a known vulnerability and has to be currently controlled on the outside. There are some technological proposals to how to do this, but currently that is a known vulnerability. But there are incentives against this, right? The probability of a single entity getting more than 51% is decreasing as time goes on. All right, so step 4, you solve it. So this eventually will be done. There's enough incentive that this person picked the right nonce, that you have a long prefix of zeros, that's sufficient, and they collect a small transaction fee. So there's part of the incentive model. In figuring out what number of transactions and the nonce value that actually generates that. They've solved the nonce puzzle, and they collect a small transaction fee. And then the final step is they broadcast that fact. Now, the others can say, OK, thank you, solved it, next problem. So they go on to the next block and the next block and the next block, and they keep appending transactions and building blocks. But there's race conditions here and vulnerabilities, OK? I'll show you a little example of one of them going forward. So here's a summary of those steps. And with a little nod to the fans of South Park, you broadcast the new transaction appears. The Bitcoin network appends the transaction, attempts to solve the puzzle, solves the puzzle, and broadcasts on it. And for you, profit. OK, if you're at South Park, but step 2 is not you, right? You do that transaction. So that's tongue-in-cheek here. So here we are, slide 22. And I finally, this is the first time you've seen this word blockchain. So when I say that the block gets broadcast, essentially, what do I mean by that block? Well, remember, in solving the puzzle, I picked a subset of transactions, okay, that have not been validated yet. They're appending on, and I'm trying to find that nonce value. Once I've found that value and I've solved that computational puzzle, that block now becomes the candidate for the next block in the blockchain to be added. So that block that I just found the nonce is appended here. I'm growing to the right in time. And these are the previous blocks that have been solved. So this is a solution for achieving distributed consensus, right? The idea being that I make it hard for everyone. That's a fairness issue. I make it sufficiently hard that no one has great advantage in always solving the problem. That's effectively you have a chance and you have a chance. Although you have to have some pretty beefy hardware nowadays. In fact, dedicated Bitcoin hardware built on ASICs that are custom built for this that get old with time, and you have to refresh the hardware. So you can read all about the hardware aspects of this. But you're still vulnerable to attacks. The next slide will show you some of the attacks. So I don't really cover the details of the attacks here. But they're live. Some may still exist that are undiscovered. That's one of the potential problems with this. And I'll discuss that briefly. So the latest valid block is appended to the end of this chain. And that is what's known as the blockchain. Here's one of the vulnerabilities. So the latest valid block has to be appended to the end of the longest chain. That is not a requirement, but that is a best practice. So what if 2 entities or more solve the nonce puzzle at the same time for different blocks? Notice these are different transactions than this one. This is the one we've been using as an example. This is a different one, right? And says, nope, I get to be the next chain. What if they say, I'm not listening to you? And they ignore something coming from another entity. Okay? So there is effectively a race condition here. This is a known vulnerability, but the probability of someone extending the chain 2 or 3 before other people have a chance to see that, actually it's, you know, the probability of it happening and being able to take it has to do with that 51% ownership, you know, if they try to corner the Bitcoin network. So the probability is quite low that this will happen. But that's based on current mathematics. There might be a vulnerability that they haven't discovered yet. So. All right, let's dive down deep on some of these transactions a little bit and show you some of them in more detail, because that's the jumping off point for the use of blockchain for more than the transfer of Bitcoin. Okay? So this is why we spent 22 slides essentially describing how Bitcoin works, but the title of this talk is blockchain. So blockchain, a generic protocol for transactions. Okay? So not just transfers and not sending and exchanging money, but a protocol. So think of this here, that instead of the actual, you know, number of Bitcoins and the actual person's identity being here, effectively, blockchain is highly dependent on public key encryption, right? So the private and public key pairs, and not just per person. You can generate these for each transaction. You have to keep these in your wallet, right? The actual fact that you have a private key, okay, if you lose that private key, you've lost your Bitcoins essentially. So That's what you keep in your wallet, and you do not divulge that to others. That is the key to the castle here, okay? So these are how you're known, right? So those public keys, essentially the hash, using those as a hash, and parts of that, these are not real public keys here, I'm just showing. And I showed you how you have to, in my original part of the talk, I actually showed the private keys here, but they're just nonsense ones I made up, but still, the idea being keep those private. So again, you're known as these entities, and of course, in the real world, these are just numbers. They're not colored like that. So this just shows that there's a shift from one entity to two entities here, identified by the public keys. The whole thing is, the transaction is signed by this sender, okay? But the important part, and there's a lot of other actions, so pointing to a previous transaction and so forth, and that's really a hash pointer to the previous transaction. You can read all about the details of simple transactions, but what I want to focus on here is the script part of this. So the way Bitcoin works is it doesn't say the transaction is not fixed on inputs going to particular outputs. There's actually a scripting language that implements that and a program that executes. Okay? That's really what gives that general purpose mechanism and what is generating all the excitement around blockchains. Okay? Initially, this was done to do these sort of transfers, and they're very simple. And I'll show you an example of some of these scripts here. So these are just some standard transaction script, again, focused on Bitcoin. But here, pay to public key hash. So the script in this case duplicates the top of the stack. So it is a stack-based language and not Turing complete. You don't have loops, for example, okay? So no looping. So you can actually talk about termination, right? Because you want to limit. You don't want an arbitrary program being embedded here. So you duplicate the top of the stack, hash that. You push another value, which is the public key hash part of the transaction, on the stack. Verify their equality, and then check the signature on the transaction. If the whole part of that leaves true on the stack, the transaction works. Okay? If anything else but true is left on the stack, the transaction failed, it's invalid. So that's an example of a program. So here's the quiz. So that's one question of the audience. What language is this like? What programming language is this like? Anybody remember?
It's like Forth.
Forth! Exactly. There you go. If I had my prize, you would have got it.
Somebody old enough.
That's right, yeah. In fact, PostScript was based on Forth. So anyway, so yes, it's a Forth-like language. It's a stack-based language. Every operator either manipulates the stack, places something on it in this particular case. Here's a pay-to-script hash. Multi-sig, you can actually do multiple payers, multiple payees. So, and then here's what I want to turn the attention to, this final operation here called null data. That's this op return operation, and then 0 to 40 bytes of data. Arbitrary data. So now you have a public ledger, visible to everyone in the world, with decentralized control, that I can put 40 bytes of whatever up on. Interesting. So, guess what? There's a website called Coin Secrets that literally goes through the whole transaction history and says, what have people put up there in those 40 bytes? That's the whole purpose of this site. And there's some really strange stuff in there. Remember, this is completely decentralized, right? And validated. So the fact that there's public key encryption going on, that you're validating this, okay? You could store data either in that 40 or what's called off-chain or off-block. So this might be a URL to storage somewhere on some cloud storage, right? So this whole, this is a GitHub project, basically name registrations on the chain. So this is the jumping off point for the next level of applications to be built on top of this. So that's why. So this is the big crescendo of the talk, is Bitcoin really was just the beginning, right? The general purpose mechanism built inside blockchain now enables all sorts of anonymized sending of arbitrary data and maybe complex programs and so forth that could be expanded on that scripting language and so forth. Here, for example, is something called proof of existence, which you have a document. You want to prove I wrote it at this date and time. So you hash the document. You just have a hash. Those become your 40 characters, and they basically commit to the blockchain. Therefore, you've effectively done, what's it called? What do we do this in real life? A notary. You've notarized it. Okay? Basically, this is decentralized notarization. Here's a guy who just, when was this? Last Thursday? His child's birth. Okay? I think in an op return. So, there we go. So, this is a big picture of all this happening. So, we start off with this currency of transfers and payments. Things like tip, so I can tip somebody through doing its standard transfer like I showed you. Crowdfunding, right? So using Bitcoin to pay for crowdfunding projects. I don't want them to know who I am, but I support this particular effort and so forth. To pegged services, so really naming, identity, ownership, membership, the notarization, even voting, right? So there's voting schemes built on top of this.
Are there voting schemes on top?
Yeah, I haven't looked at them in details, but I've seen people trying to do voting, for example, on top of this. Now, whether it works, a lot of these are very nascent technologies, right? We're about here in evolution, right? People are thinking and have prototypes for up here, but it's going to be an interesting decade to come. So now we move up to things like smart contracts, right? So, for example, I have a couple slides where you put, I was talking with John, maybe I should put the deed to my house, right? Somehow put a pointer to the deed of my house, right? Right now, it's these banks. There was a system called MERS, Mortgage Electronic Recording System, that basically during the housing crisis crashed. They couldn't keep track of who owned what fractional parts of mortgages, right? When they bundled the mortgages. It got too complex. And I think they went bankrupt, but they came out of bank. I just went to their website before this talk to see if they still exist. They do. So the idea being here, blockchain could serve as that arbiter between and be recorded, right? So maybe we should put our houses on this too. Now, who would enforce that, right? So we still have laws and courts, but this could be an effective documenting mechanism to bring to that court if they could be convinced that this is a way that was recording that was valid, right? Instead of in a filing cabinet in a courthouse or in some electronic MERS system in a single company, right? Okay? You could see, I could see in the next 10 to 20 years where the courts maybe could find in favor. That's, a toss of the dice sometimes. And then finally at the top here, there's really decentralized autonomous organizations. In the abstract to this talk, I talked about distributed applications and so forth. So I'll show you a company called Athyrium that's really thinking along these lines. What if you have like one of the self-driving cars? But it's not owned by anybody but itself. How would it bill? How would it enforce that it has income? How would it pay for things for itself? It could use currencies, right? Document its ownership. That's what's meant by transportation here. So that's the autonomous part of it, right?
Is the incentivization still there for people to be the authorities?
So currently, the mining amounts are gradually decreasing, right? So the reward for when you do an originating block, essentially, the price, I think it halves every, I forget the number of months, right? But transaction fees, right, are going to be the way of essentially getting the money. And they think that those transaction fees, are worth it.
So they'll apply even if it's not for currency transfers. If it's for
exactly, right. So the other thing I said, and that's a good point, in the abstract to the talk, I talked about altcoins. I'm not really going to mention them, I'm sorry, but I'll mention them now. Altcoins are, well, if you can do this with Bitcoin and you have the Bitcoin network, right? Well, you could do the same and have other blockchains, right? So people have just started from zero again. They have variations on the whole blockchain technology that support more or less some other. So there are these altcoins, which are whole new blockchains, right? When we talk about Bitcoin, we talk about a blockchain, right? A singular blockchain, not stored in a singular place, right? But effectively published since the beginning to now. At the frayed end, there's controversy about who's appending the next chain, but more or less there is a singular chain. So there's all sorts of altcoins. How do you incentivize that, right? So it's a bit of a chicken and egg problem, right, to get people to hop on board. Some are failing already. They didn't choose a proper incentive model, so it's open work. So this is what it's thought. You obviously have, there's not too many of those up here necessarily, and then increasing to us using a currency. So this is a kind of a big picture that comes from that reference there. Any other questions? Yeah.
Are there limitations to any chain? Growth limitations, and then it stops?
No, because numerically, you're talking about numbers of primes and hashes and so forth, and that's a very big space, right? So number of grains of sand in the universe and so forth type of expansion. So I don't know of any limits beyond that. So it has the capacity, right, to grow in the upward direction. So you may think, oh, this is going to reserve for really important transactions, not just for fluff. But no, you can, the number space is quite large. So here's something on smart contracts, okay? Similar to like the house deed, but what they're thinking is, you and I have a contract. It's enforced by some mechanism. Well, where is that going to be recorded and necessarily enforced to go back? So you could put that in the blockchain. You could have the contract off-chain, hash it. Basically, then, if someone tried to change that, the hash is unique for that particular artifact. So using that for smart contracts. Here's the company Athyrium. Yes?
Can you associate, like a digest, MD5, can you associate that with a financial transaction?
Oh, it's an interesting off-chain transaction. Yes, yeah.
I'm giving you so many bitcoins, and here's the contract you and I have signed.
Yes. So there are mechanisms, for example, for handling breach of contract. What if somebody simply goes offline? There's an escrow mechanism, okay? So if you dive deeper into this, actually within the standard blockchain, there are ways of doing operations that effectively do those scripts, okay? For doing escrow. And essentially, if the person doesn't claim the money within a certain period of time, it reverts to you for effectively breach of contract.
I was just thinking, I was thinking the case where, you and I agree, you're on my lawn once a week, and I pay you this amount of money, and then you can buy and only do it twice a week, or every other week. And I say, wait a minute, I paid you to do it.
So you might use an escrow mechanism to that, because if you transferred initially, then that was appended to the blockchain and that's gone, right?
Okay.
But there are ways of effectively apportioning transactions over time tied to a previous transaction. And in the case where you're essentially promising that there will be a transaction on the chain that's placed, or else some other remediation. Yeah, the escrow mechanism is quite sophisticated. Okay. So the interplay of how to play over different blocks, how to structure the transactions so they're valid or invalid. So the payments are either apportioned in time for work done, or there's an escrowtized type of mechanism where you're eventually paid. And if you don't pay the escrow amount, I do the work, there's enforcement that so it can get quite.
I want to take you to court because you're only mowing my lawn every other week, and I said you've got to do it every week.
But you can enforce that through the proportional payment, right? Exactly.
As long as there's a MD5 tied to that transaction.
Right. Exactly. So it can enforce those types without the court, essentially. So yeah. Ethereum is a company that is actually trying to build general purpose computation on top of this. So not just the embedded scripts necessarily, but the ability to write a program, have it farmed out and execute on storage, and then essentially, so these are distributed applications. It's quite bold, proving, but they have released an SDK, proving termination, cyber vulnerabilities and so forth. They're very bold in this space, right? They're moving up that chain very, very quickly. But they are essentially trying to do distributed computation without centralization. So And then smart property. This is really putting your deed, okay, as part of the transaction. So you could enforce it and show ownership and so forth and not have to rely on governmental entities, essentially. So this is all very much in the contemporary news. That was last year. Pros and cons. So here's the source for this, a book called, a short sort of handbook called Design to Disrupt. I think it's free on the web. You can get it. So the pro, freedom of payment, right? So I don't have intermediaries and middlemen. I can pay you. It's just between the two of us, right? You pay the transaction fee to the network, but that fee is very low, right? Okay, it's a very fractional amount. I actually did this myself with my own wallet. I had 0.004 Bitcoins, or 0.005 Bitcoins, and then I decided to move it from one wallet to another, and I paid 0.001 Bitcoins transaction fee, and I was left with 0.004. So that's what I have at the moment. Let's see. Micropayments are going very well. Okay, people are using this to ship very small amounts. Oh, so I showed amounts in whole Bitcoin, right, just for simplification. But the way these are actually done is they're fractional, 0.0001 Bitcoin or something like that, right? So they are done in millions of Bitcoins or so forth, so, or thousands of Bitcoins, millibitcoins. Transparent and neutral, we see that. You've got the public ledger, essentially. No one owns it. Banking the unbanked. So we have people that don't have bank accounts. This is a way that, Africa, for example, has many people using mobile phones. This would be a way, an entry point for them to maintain, essentially, a balance, right? Without having a bank. Protection and control, right? So if all the crypto works in this, then essentially, you have that, and if you keep your private keys safe, offline, there's actually mechanisms for keeping those wallets, like even on paper, okay? And you can keep those physically in a safe. So they're offline and can't be broken into, for example, at least electronically. Lower the risk for sellers, okay? So this gets back to the escrow mechanism. You can build these sort of things into, and I would encourage you to look at the escrow stuff. It's quite sophisticated on how to enforce that. The cons, though, are replete. Limited adoption at the moment. Not everybody's taking them, right? How do you spend the Bitcoin, right? We hear about places taking it, but they're onesie, twosie, this exotic hotel, restaurant, cafe or something, but it's, I can rarely walk into a large place, but increasing every day, I think. High value volatility. So we've all seen the value of Bitcoin to the dollar go up and down and up and down. And so if I'm buying it one day, what am I getting? And am I buying low, selling high, and so forth? So there's reluctance to invest in this, essentially. It's still shaky and unfinished. There are vulnerabilities that might be undiscovered. We're not sure. So, and here's a big one that we always hear. We'll talk about this in a couple slides again. Facilitates illegal and dubious practices, right? So you can have drugs and other types of transactions. So this offers protection to those. Thank goodness I haven't heard the Paris bombings were surprised. I think PlayStation got the finger this time, but certainly this type of mechanism could come under suspicion. No recourse to authority, right? Who am I supposed to go to if my wallet's stolen? My Bitcoin, my key wallet. Coins can be stolen that way, right? So there are vulnerabilities in the private keys and their storage, and it's new and unfamiliar form of supervision. We're used to hierarchical entities and invoking that type of authority. This is decentralized, and we're not familiar both socially, legalistically, of controlling that. So here are some quotes to show you both sides of the coin. The green are supporting, the red are detractors, right? So we get people like Paul Krugman, it's evil, to Bill Gates. It's a technological tour de force, right? So, what are we to believe if we get all, signal from both sides of the coin, so to speak. By the way, is the Bitcoin symbol, if you're not familiar with that, right? Okay, some final notes. Bumps in the road ahead. So it is definitely not smooth sailing. It's an important technology, I will say that. It's important to know and to study and to be aware of, okay, regardless of the pros and cons. I'm always reminded of Richard Feynman's quote, which he says it's from a Buddhist monk. To every man is given the keys of the gates of heaven, but the same key opens up the gates of hell, okay? So it's up to us to use how to decide that, right? It is not the technology. It is inherently evil or good, It is effectively neutral, and that's how we use it and employ it. Right? Criminals use the roads, right? Criminals use cars to rob banks. Do we outlaw those? And okay, so no. So money, for that matter, is a similar case in some cases, at least cash. So existing and undiscovered vulnerabilities, right? I talked about the 51% rule. Are there zero-day attacks? Right? So these are attacks that we have not been practiced before but are waiting. And wallet security problems, so protecting your own private keys and access to that, right? That's still a vulnerability, and that's up to you. Performance. So I said there was a 5-step process. You broadcast that initial transaction. Well, when did my money get transferred, really, right? Was it when it was appended? No, it doesn't seem likely. When it was the block Nantes puzzle was solved? Well, that was only one server. What was broadcast to most of the network? Well, what if somebody has a competing block that it ended up on the chain and my block had to be resolved and appended later? In fact, the performance is exactly that. It's minutes to hours per transaction. When I said I transferred that 0.005 Bitcoin, I think it was about 2 or 3 hours before I got effectively the final confirmation that that transaction had been fully processed. And what that means, there's only a rule of thumb that basically after 6 blocks, right? So your block is appended, your transaction is part of a block that's appended, and then 6 blocks after that occur, that you can sufficiently be more or less safe that no longer chain is going to compete with that, okay, and switch over. So that's the current rule of thumb.
Does this scale, in other words, as more and more uses of this come into play, does it get slower and slower?
That's a good question. I don't know, and I think that's one of the open questions is performance. If this becomes, a major, what we've seen with peer-to-peer networks is that the answer is yes, but they can scale quite nicely. So there are people who say that this will scale properly, but if you add some of the countermeasures to, that might slow it down. So I don't know the answer to your question, but that is an open question. The future. I think there's going to be a lot of FUD. So if you haven't heard this term before, fear, uncertainty, and doubt. A lot of this is orthogonal, right, and flies in the face of current centralized institutions and processes who their livelihood is at stake if something like this is successful. So they will trump it up, the weaknesses and so forth. But I don't think we should overlook the potential advantages, right, as well. So I think there's a definite, there are definitely risks that we have to be aware of, but the possible benefits that could come out of this as well. We should treat it that way, yes?
And on the future, will there be competitors to blockchain?
Well, the altcoins, right, are a whole new blockchain. The basic technology, maybe your question is not necessarily different blockchains, but a whole new different technology that builds on this. Yeah, that would be exciting, right? That solves some of the problems, maybe the performance issues, makes this more real time. I haven't seen a lot of work on that on alternative because this was quite a sophisticated technology to come up with, right? I mean, there's a lot of mystery around the author of Satoshi Nakamoto, right? Who we don't even know who this person is, essentially, right? So there's stories on trying to find out who it is. So it would be exciting if somebody came out with the next technology, but I haven't heard anything about it yet. So good question. So, but I think one thing is for certain, it's here to stay, right? Every day you see things like this. So this just hit me. It was kind of a surprise. So the country of Estonia has been quite innovative, right? So they're asking NASDAQ to come in and design all these sorts of things, contracts, property deeds, and so forth, and design a system so they can run their country on this. So, here's a stock market firm that's going to build on this. And they're doing it to get experience to bring that technology to bear in other market spaces. So, again, we should look at this as a technology, be aware of its strengths and weaknesses, and move on in a rational and scientific manner. So that's all I have. Any questions? Here are the credits for various pictures and lots of stuff to read. I've given you a couple particular articles, but that's not all there is out there. Every day there seems to be another book.
I'm gonna say that online course has a free download of the book if you go to it.
Oh, yes, I think that's where I got it from. Yeah. Yeah. So put a plug in for the Coursera course taught out of Princeton, and it's quite good. Yes, yes. So Ed Felton and colleagues produced that. It's quite good. Yes, it is. Unfortunately, it just ended.
Yeah.
So I think it ended mid-October, mid to late October, and I'm not sure when they're going to teach it again, but.
We're still working on the book, right?
Yeah, they had the last 2 chapters are still under development. So. And they do dive down deep into the structure of transactions, the escrowtized chain, and so forth.
But it was interesting, your point about this. In reading their stuff, I did not pick out generic scripts.
Yes, they really focus on Bitcoin and the details of the transaction model and script. They do not really, I mean, they have parts on blockchain, right? But they don't go into a lot of the ramifications for the future. That pyramid that I showed back here, which I think is really a good picture of, yeah. So that's in the book, but they do that as circles. I redid it as a pyramid. So you've never seen this before. This is my own invention, and it's a sort of a riff on their circle diagram. So I didn't want to just lift it out of the book, so I reformatted it.
So the block, sorry.
Questions?
Okay, so the blockchain needs to broadcast to everyone when a transaction happens?
It doesn't need to broadcast to everyone, but a sufficient amount of the network that a consensus forms that they agree to what the next block of the chain is, right? So, yeah.
Is that still necessary to, I mean, is that 2 parties, like the buyer and the seller, they agree? Is that sufficient to exchange? Why does it need to broadcast to?
Well, they need to ensure that, in effect, once they solve the nonce puzzle, they don't collect the transaction fee at that point. They have to be the next block on the chain, essentially, right? And that's a consensus issue. So they've got to show, and there's what's called proof of work, that they've solved that puzzle and tell a sufficient amount of the rest of the Bitcoin network that they've done that. And once a consensus forms, right, not everyone, but a consensus that that's the next chain and that we're all moving on to the next block, right, then essentially you've succeeded, and your block that you solved the nonce puzzle for is now part of the blockchain. Now, it could be that 2 or 3 blocks are appended, but the rest of the network then overrides that with an alternate path, right? Yeah. So there's no guarantee. That's why I said you wait 6 blocks, right? So
6 blocks.
Yeah.
Still a little bit, maybe low probability to be.
But it's a very low probability, right, that you would be overridden. As each, it can be measured, there's mathematics behind the curve of as each block is appended and a consensus done, it's 0.00001% chance that a new chain.
It's definitely an issue for the scalability. If you have a large number of people, the consensus itself, I mean, to build up the consensus, time consuming.
Absolutely. So you need to keep the incentive high enough to attract that 51% mark, right? So you get a single company that owns multiple nodes, right? They're going to monopolize that market. So you need to have the incentive model so people invest in the hardware to do this, and that can prove a difficulty, particularly for altcoins, right, entering the market, right? What's to incentivize them to build a whole new chain, to spend all the hardware and so forth? But people are doing it and thinking about it, so.
I mean, for a big, this very very busy business day, like Cyber Monday, so for example, billing transactions, this is a crash.
I mean, the other thing is, one thing not to underestimate is the value in all those transaction fees, right? So if we think about the money in advertising, the money in bank transfers like globally and so forth, there's a lot of money to support the transaction fees here, right? But it's in our traditional institutions now. It would effectively have to disrupt those markets, and all that money, right, value would essentially move over to a mechanism like that. Those institutions will not like that and will essentially fight that, right? So they don't want to lose that bit, or adapt, right? So they'll adapt to these sort of mechanisms, right? So that's what's disruption. Yes?
You mentioned that the Nantes puzzle gets harder and harder to solve over time, so then would require more beefy hardware. So how do they make sure that that doesn't prevent others from creating computing nodes?
That's a good question. So fairness and creating entry for the market. So I mean, that's a very good question on how to retain that incentivization for collecting the transaction fees and investing in the hardware. That's a real concern going forward. Yeah.
And this may be wrong, but I believe it's not that it necessarily gets harder every couple blocks, whatever it is, but it tries to average out so that it takes about 10 minutes.
Yeah, that's right. Yeah, sorry.
So if there's suddenly tons of computing power, it will get harder, but then if it goes away, it'll get easier. So it's not always.
It tries to keep the average of 10 minutes. That's right. Yeah, sorry. I did say 10 minutes before, didn't I? Really? So you're trying to maintain that average of 10-minute solution time. Yeah.
Now, all of the algorithms or code even to do all of this is public, right?
Yes. Yep. So
I imagine some performance issues are proprietary, if I can make it go faster.
Probably.
But basically, the algorithms are all.
Absolutely. Yeah. That's part of the transparency neutral part that this is supposed to be for the benefit of all of us.
That whoever it was that invented all of this has a secret back door, but it's hard to imagine that.
Well, my 0-day vulnerability, I put that on the list. So
To itself.
absolutely. Any other questions? Thank you very much. This has been fun. So appreciate it.